Good morning, everyone. My name is Navya Canumalla, and I am a program manager on the Microsoft Identity Platform, specifically working on authentication SDKs and developer experiences. Today, I'll introduce you to the Microsoft Authentication Libraries, also known as MSAL, for Java and Python applications, and show you how to quickly get started with them. Let's take a look at the agenda. I'll start with a brief overview of MSALs and the benefit, followed by the supported scenarios and common calling patterns in Java and Python applications. I'll show you a demo of the Quickstart experience to get a sample app up and running. I'll talk about token caching in advanced scenarios. Finally, I'll cover some details on migrating your applications from the previous ADAL libraries to the latest MSAL libraries. At various points in the talk, I'll ask you a few poll questions, and I'll also leave some time at the end to address any questions you have. The Microsoft Authentication Library is basically an authentication SDK that enables your applications to authenticate using Microsoft identities such as work accounts, organizational accounts, or personal accounts. And it also issues access tokens that allow you to access APIs secured on the Microsoft Identity Platform. Some of the benefits of using MSAL are that the MSAL SDK implements OAuth protocol. So as a result, you get APIs that you can call to perform different OAuth flows based on your scenario without having to know the implementation details of the protocols. Another benefit that MSAL provides is that it is mainly a token acquisition library. It is meant to be used in client applications to get tokens so that you can access APIs. Here, client applications refer to any kind of application that is accessing some kind of a backend service or an API. So think of web apps, desktop apps, and such. With MSAL, you can acquire tokens not just for a user's identity, but also as the application's identity based on your scenario. MSAL provides a token cache, and it takes care of maintaining this cache and refreshing the tokens before they expire. Recently, at the beginning of this year, we announced the general availability of MSAL for Java and MSAL for Python libraries, which will support different types of applications that can be built in Java and Python ecosystem. All of the code for MSAL is open source. You can find the MSAL repositories on for Java and Python on GitHub. Do go check out these repositories, and you will find the usage and wikis to help you get started. If you have any feedback and questions, feel free to open issues on our GitHub repositories. We actively look at them and triage them. MSAL Java is available in the Maven repository and is distributed under the name of MSAL 4J package. You can install this package by adding the dependency to your application's pom.xml file if using Maven. If you're using Gradle, you can also add the dependency in your build.gradle. MSAL Python is distributed through PyPy, and you can install this package using the pip installer for Python. If you want to get more detailed docs, you can start at these short URLs for MSAL Java and MSAL Python docs. aka MS MSAL Java docs and aka MS MSAL Python docs. Let's talk a little bit about the supported scenarios. I will go into more detail in further slides. So Java and Python applications can be built on different types of platforms, and they are of different varieties of applications. MSAL provides support for these. MSAL for Java and MSAL for Python can be used to build application on the Windows, Linux, as well as Mac OS platforms. The different types of application scenarios supported today are web apps, desktop apps, like apps that run in the operating system, like Windows, Linux, and Mac OS, Daemon apps, which are like background services or jobs running in the console, applications without a browser, for example, IoT apps, and web APIs. In the core object model, MSAL Java and MSAL Python model their application types based on the OAuth client definitions, namely confidential clients and public clients. So confidential clients are applications that run on servers and are considered difficult to access. As a result, they are secure by nature and are capable of keeping application secrets secure. Web apps, web APIs, and services or daemon apps running on the web are considered confidential clients. In MSAL, you can create an instance of the confidential client application class by using a distinct client ID and client secret. Public clients are applications that run on devices or desktop computers. These applications are not to be trusted with maintaining application secrets. So they need the presence of an authenticated user in order to make secure web API calls. In MSAL, you can create an instance of the public client application class with a distinct client ID as a minimum configuration. One of the key APIs MSAL provides is the acquire token method. These methods allow you to get tokens for APIs in different application scenarios. We will look at the details of these application scenarios and their calling patterns in some time. At this point, I'd like to pause and have a quick poll. What type of apps do you develop in your organization?
Okay, we have some answers coming in. Web, Daemon, console plus web, desktop, web, web
great.
app.
So it
scripts.
sounds like a lot of web apps, but also a spectrum of different types of daemon and scripts and command line apps. Okay, that's good to know. Yeah, thank you, Stephen. That's great. Another question for you is, if you are building web apps, which I see that most of you seem to be building web apps, what kind of web frameworks do you develop the web apps with, if you do use any frameworks?
Okay, answers coming in include Python, .NET Core, Angular, SPFX, Q2 Angular, Spring MVC, Spring Boot, .NET MVC, .NET Core, Blazor, Java plus Angular.
Great. So I see that there are more than just Java developers. So there are like .NET and Angular. So some of these topics would still apply to .NET as well, because we on the MSAL SDKs try to keep the APIs consistent as well as keep the flows that are implemented the same across these application scenarios. So some of this talk still applies, but we will be seeing APIs and code very specific to Java and Python. So thanks, Stephen, for reading those out. Moving on, we'll go a little deeper into the application scenarios that I mentioned. Starting with the web app scenario. So the web apps are considered as confidential clients in the MSAL. This is because they can run on a server and store app secrets securely. Consider a web app, for example, as an employee dashboard, where you're signing in employees of the organization, and you want to access some data from APIs for this employee. So here is a some of the code that you would write in Java and Python MSALs. To get an access token for a web app to call a web API, MSAL implements the authorization code flow. In this flow, an authorization code is obtained when the user signs in, and then this code is exchanged for an access token to call the web API. Here, the token is representing the identity of the signed in user. So in MSAL, you would start with instantiating a confidential client application with a client ID and a client secret. You can also provide an authority. An authority here is basically the endpoint of which includes the tenant in Azure AD where you want to authenticate users from. So you are optionally able to provide this authority string here. But at the base configuration, you would provide a client ID and a client secret to instantiate the confidential client application. And then you can set up the authorization code parameters for the flow and call the acquire token method. So in MSALs, we follow APIs that are idiomatic to the language. So in MSAL Java, we use a builder pattern. Whereas in MSAL Python, you will see that there are multiple acquire token methods based on the flow. However, we use very similar constructs and the core object model are close, so that it is seamless for you to work with multiple MSALs and multiple languages. So let me show you a quick demo of a web app sample here and show you how easy it is to get started. That I'm just going to go to my demo tenant in Azure Active Directory. So I have my demo tenant open here. I will go to the app registrations blade and start with, you can see your existing created applications, but I'm going to start with a new app registration. And let me give it the name, like some name, my web app. I'm going to select, you can select the different types of accounts you want to support. Suppose you want to sign in users only within your current Azure AD directory, you can do that. If you want to expand the access to more than just your Azure AD accounts, but also to personal or any Microsoft identity, you can do that. For now, I'm going to select my demo tenant only. And this is optional to provide the redirect URI. You'll see in a bit. So I'll just give this and then register the application. So now you will see in the left-hand side that once the application is created, you can see a Quickstart blade. So in the Quickstart blade, I'm going to select the web application tile, and you will see a range of different frameworks and languages here in which we have provided some of the quick start samples. I'm going to pick Python. So here you will find the detailed quick start steps to configure and run your Python application. But the cool thing is here you can just click this button and the portal experience will set up some of these configuration for you. So over here, I'm going to be adding the redirect URI for this web application. And it's going to also create the client secret for me so that I don't have to go do that on another tab. And also set some of the permissions for accessing an API. In this case, we are calling a graph API in this quick start. So I'll just click this button and let the portal experience make these changes for me. There. So it gives you a chance to note down the client secret if you wish to, but you don't necessarily have to at this point because it does configure it in the application. But if you want to use the secret later, you might want to note it down. So it says application is configured. The next step is just for me to download the code sample. So quickly download that. Okay, that's downloaded. So I'm going to open this and just move this into my directory. Okay. Okay, great. So I'm going to just show you what the code looks like and how it's configured. Okay, so as you can see, the client ID has been set and even the client secret, and we have also the permissions here, which are set as the scope parameter. So some of this has already been configured, including the redirect path. And this was all set when we created that, when we clicked that button in the portal experience. Okay, so next step is to basically just copy the command to install the required packages. Yeah, it's installing them there. It's done. And then we can just run the command to launch the application. Okay, and the application is running. So I'm going to just quickly show you the application. I'll open a new session here and start up the application. So you get a sign in button and you can just start there. And I'm going to use my test account here to sign in. Okay, and now I'm getting a consent screen after I log in to consent to the permissions that we are trying to access. So in this case, I'm trying to read some of the profile information from Microsoft Graph API. That was the permission that was set for this application. So it's allowing me as the user to give my consent to that. So do that. And there, we are signed in. It says welcome Navya test. So it displays my username here. So that shows that I'm signed in. Now I can go ahead even make the Graph API call. So let me do that. And there it returns the result from the Graph API call, which was basically to list some of the users in this demo tenant. So here it lists some of the information about the users in the tenant. So it was that simple to get it up and running.
Navya?
Yes, go ahead.
There's a question right now. Somebody's asking, what if you already have an existing Python app? What do you install and how do you configure it to use the MSAL Python?
Sure. Yes, this is an app where this is a Quickstart experience where we newly created this app, but definitely you can use it in an existing app. What you would need to do is, let me just show you the, yeah. So what you would need to do is basically install here we have a file with all the packages, but basically if you want to just start with Python app for MSAL, you can just pip install MSAL, and then you will have the MSAL package installed with the latest version. Once you have that installed, we will go into some more details of the code, but you can see here in this application, you would have to basically import the MSAL package into your app and then configure some of the confidential client application, if it's a web app in this case, with the client ID and the client secret, which is already configured in this app. But you would basically set those as the config parameters in your configuration file, and then pass it into this confidential client application class to instantiate it. Once you have that, you can call the different types of acquired token calls and methods. So in this case, if you're a web app and you want to do this for a user, you can call the acquired token using the auth code. So you can call, that's actually included in this request here, but you can use the different acquire token methods. And I'll go a little more detail into the calling pattern of MSAL in the further slides. Hope that helps answer the question about what to do if you already have an existing app.
Yeah, there are a couple more questions right now if you want to address them. One is if you can show in the requirements.txt what's specific to MSAL in there.
Yes, sure. So specific to MSAL is just the MSAL SDK. We are at, I think, version 1.3, which is the latest right now. But yeah, you can provide your version number or range. These other things here are more for the framework that this web app sample is using. We've used Flask here and we've used request, but you can change that based on what is applicable to your application. But the key thing required for MSAL is just the MSAL package.
All right, and one more question for now. What's the difference between using Spring Security versus the MSAL library?
That's a great question. So like I mentioned before, MSAL is a token acquisition library, and it provides you some of the APIs to get the tokens, like the acquire token methods. And it can be used with the Microsoft Identity Platform specifically. Now, as far as I understand, Spring Security is also it is possible to integrate the Spring Security with the Microsoft Identity Platform. However, you would have to configure some of the details like the endpoint that you need to provide to the Spring Security for the Microsoft Identity Platform. Some of those details are abstracted in MSAL SDK. Having said that, MSAL SDK is very specific to token acquisition, whereas I think with Spring Security, you can do even things like token validation if you're building web APIs and are trying to protect your web APIs. I will cover a little more about this, and I had some questions for the audience here based on this scenario later down in the deck. But that is at a high level. So we do have a sample where we show how to use Spring Security with the Microsoft Identity Platform. But the MSAL SDK is more tailored for token acquisition scenarios, and it covers a multitude of application scenarios, not just web applications. I hope that's helpful. So if there aren't any further questions about this specifically, I'd like to move on with this.
No other questions for now.
Okay, great. We can talk more at the end about these scenarios, and hopefully you'll have more questions then. So that was the demo. So as you can see, it was really easy to get started with a new application. And pretty much some of these principles apply to existing applications. So you can find more of these Quickstart and samples also in our docs. But I'd like to pose a quick question to the audience here. What other Quickstart or samples would you like to see? If there are any scenarios on top of your mind, please type it in the chat windows.
We're starting to see a few responses coming in. Token cache and how to get tokens silently. A more complete web app rather than a simple hello world app. Managed identity and distributed cache. Okay, yeah, these are all great scenarios, and I'm happy to hear these because these were also on top of our mind for the next set of samples we want to build. So it's good to hear that this is what everyone is interested in. So thank you for providing that feedback. So I'm going to move on to some of these other scenarios and quickly go through some of the details here. This other type of application scenario supported is a Daemon app. So a Daemon app is basically an application that can run in the background or as a script in a console, which doesn't require a user to be present. So think of an Python script or some kind of a command line application that's running and processing some data from a blob storage API, for example. So this doesn't require an
user to be present. But this application would also be modeled as a confidential client application since it runs on a server and can be securely maintaining a secret. So the pattern is very similar. You create a confidential client application object and then call the acquire token method by setting up some of the client credential parameters. So in this scenario, the MSAL uses a client credential OAuth flow. This flow basically uses the application's client ID and client secret and identifies itself to the identity platform to get a token for the API. So here you would provide the application ID and secret as a part of this flow. The next scenario we have is like a desktop app scenario. So desktop apps are both console applications as well as some of the native applications that are in the operating systems like Linux, Windows, and Mac apps. In this scenario, there are a few different flows that can be used, but I'm covering the most common flow and the most recommended flow here, which is using the authorization code flow. Again, this is very similar to the confidential client authorization code flow. And a quick note here, the desktop apps are generally public client applications because they are systems which are they are applications that are native to the systems which are openly accessible, and hence they are not considered really secure and able to maintain secrets. So you would here instantiate a public client application instance and then call the authorization code flow. One key difference between this and the confidential client flow is that there are some added security mechanisms for the public client flow where we use a proof of key for code exchange, which is basically like a code verifier. But these are more covered in the implementation of MSAL, and you don't have to worry about it as a developer using the API. You just need to set up a public client application instance and invoke the authorization code flow. Another type of application that MSAL supports is applications without browsers. So what does that mean? These are mainly headless applications or applications without a web browser or an interface where a user can interact for completing the authentication. Most of the user interactive flows, they require the user to authenticate in a web page with the login information. So if you have applications like IoT apps, or another example is like a command line app which doesn't have an interface, you can use this flow in those scenarios. So here we use the device code flow, which basically happens in two steps. When you initiate the device code flow, the user is presented with a URL and a code which is issued by Azure AD. So you can the user is asked then to take this code and enter it at the URL specified in another device, such as a smartphone, for example. So they can open their web browser in a smartphone and enter the code. Once they enter the code and complete the authentication flow successfully, like they will be presented with the usual consent screen and stuff. So once they've completed the authentication there successfully, then through a back channel, the MSAL SDK gets an access token issued from Azure AD for this user. And after that, the application can call the API using that access token. So this is another flow that is supported. One point I would like to mention, which I think I missed in the previous scenario, in the desktop scenario, is that there are some other flows that are used in desktop scenarios, such as integrated Windows authentication and the username password flow. The integrated Windows authentication flow is very specific to Windows machines, and it's mainly implemented to take advantage of a domain joined machine, so that if there is a domain joined identity, that can be leveraged to get tokens for the application without additional user interaction. The username password flow is not exactly a recommended flow. That's because in this flow, the application would need to obtain the password of the user, and that is highly discouraged to applications to take passwords and store them, or even just expose the passwords to the application. So in this case, we don't recommend using username password flow. However, it exists for some very specific and special scenarios, such as DevOps scenarios. So just a little bit about those other flows that are possible in the desktop.
Navya?
Yeah.
So Raki right now is asking if MSAL Python supports the resource owner flow.
So the resource owner flow is just another name for the username password flow. Basically here the resource owner is the OAuth terminology for referring to a user. So a resource owner would be represented using a username and password. So it's the same flow. So yes, we do support it. But as I said, we do not recommend using it in your mainstream scenarios, and only use it in some really special cases like DevOps scenarios, or where there is a real need for resource owner. Hope that helps. Okay, moving on. One of the last scenarios that I want to talk about is the Web API scenario. So Web APIs are interesting because they have a bunch of different scenarios we already touched upon. You can get tokens for a Web API to call another downstream Web API. And that is the scenario that MSAL focuses on because it's a token acquisition library. So in this case, you have an API like a backend service or an API which already has received an access token from an authenticated client. So now it needs to take this access token but call another downstream API. In order to do that, we provide the on behalf of flow. In this flow, you use the access token received to exchange for another new access token specific to the downstream web API. So this flow works in the context of a user's identity. And again, web APIs are also confidential client applications, so you would need to set up the confidential client with a client ID and a client secret. So that is the on behalf of flow. At this point, I'd like to ask a quick question. How I mentioned just now that this is a token acquisition scenario, but you also have scenarios in web APIs where you want to do token validation and protect the API. So just quickly, if I can get some answers on how many of you have the scenario to secure web APIs, and what do you use for token validation today? So just a note here, MSAL does not provide token validation, and this is a scenario we are considering for the future. But yeah, today MSAL is a token acquisition library, and it does not provide you token validation. Okay, please feel free to keep posting your answers in the chat window. I'm going to quickly move on to the next section, which is I mentioned that I would talk about a recommended pattern, especially when you use MSAL in user interaction scenarios. So in these scenarios, you want to avoid repeated authentication prompts to the user and want to optimize for that as much as possible. And MSAL provides an API called acquire token silent. So you can acquire tokens silently using this method. What it means to acquire token silently is that when you call this method, MSAL checks the cache for a token that exists for this authenticated user. If there is a token, it returns it. And if there is no token, or there is a token that is about to expire, it will even do a refresh and return that token all in the background. Like without prompting the user. But for any reason, if this silent method fails, then of course you will need to handle that and invoke one of the interactive token acquisition methods, which will again prompt the user. So that is a recommended pattern, especially in web apps and interactive flows. And you can see this is provided both by MSAL Python and Java, and most of our MSALs have this pattern. So that's one pattern that I just wanted to mention as a best practice in your application. So we just spoke about the token cache. So I'll quickly cover a little bit about the token cache. The token cache provided by MSAL Java and MSAL Python are both in-memory token cache, and they last for the duration of the session. So during the silent token acquisition that I just spoke about, MSAL will check in the token cache if there is an token that can be used for this user account. And it also maps the token cache by the user's account. If there is no token available, it will throw a failure. But if there is a token, but it's close to expiration, it does a refresh of the token and makes a request to renew the token. Out of the box, the token cache in MSAL does not provide serialization and persistent token cache. However, MSAL Java and MSAL Python provide an interface which allows you to implement custom serialization in your application if you choose to persist it between different application instances. Also note, we are recently developing some libraries for called extension libraries for Java and Python, which provide secure mechanisms to do some of this token serialization and persistence across multiple platforms like Windows, Linux, and Mac. So do check out these extension libraries. They're at an early stage, but you can definitely check them out. And we will be providing more samples. I heard that as a request. So we've noted that we will be providing more samples around token caching soon.
Yeah, there's a question about this. Do we need to maintain multiple token cache for multiple access tokens?
Yeah, so that's a great question. So like I mentioned, that is all taken care of by MSAL for you. As long as you're using the MSAL token cache, you don't really have to do any of the mapping of the token cache for multiple access tokens and user accounts. All of that is handled by the MSAL SDK. It has a cache format where the keys are mapped based on the user account and a bunch of different attributes, which include the different access token for APIs as well as the user accounts. But yeah, it does not give you the persistence out of the box, which you will have to implement like into a file system or into a Redis cache. But definitely you don't have to implement all the mechanics of caching, if that makes sense. That's taken care of by MSAL. So that's a little bit about the token cache. We can definitely think of more questions and we'll try to address them at the end. The last section I want to talk about is migrating to the MSAL SDK. So for those who are not aware, we had the ADAL SDKs before, which are also authentication SDKs for the Azure Active Directory. And these were used in a lot of applications, but they were the previous set of libraries. Today, we are doing all feature development and investments in the MSAL SDKs. So if you are an application that is using ADAL, we highly recommend that you move your applications to MSAL and migrate at your earliest possible. We are supporting and maintaining ADAL SDKs, but they are mostly in maintenance mode and no feature development is happening there. So it is highly recommended for you to update to MSAL to get the latest innovation. Apart from that, MSAL also gives you some further benefits. So I will cover some of the key differences you want to note between ADAL and MSAL when you're migrating your application. One of the key differences is the use of scopes. ADAL acquired tokens for resources. So most of the ADAL APIs had the notion of a resource where you just provide the resource ID to get the tokens for that resource. But MSAL provides you the concept of scopes, and it acquires tokens for scopes. So scopes are nothing but a list of strings which are representing the resource and the permissions associated with that resource that you want to request the token for. So you would need to specify these scopes as a parameter in most of the MSAL APIs, which you've also seen a little bit before. Another key difference is in ADAL, the core object was the authentication context class. This represented your connection of the application to Azure Active Directory. However, MSAL has modeled its core objects around the client types, like I mentioned. So you have like the public client application and confidential client application. These are the two different core classes that are available, and it is just more closer to the application scenarios. The other important point is that MSAL introduces the accounts object. So ADAL had a user class, but MSAL introduces the concept of account where a single user can have multiple accounts. So they can have one or more accounts with different Microsoft identities. For example, a work account or a personal account can be there for the same user. So in MSAL, you have the benefit of this because you can now sign in multiple accounts into your application and have the experience of caching and all the benefits for both these type of accounts. So that is a new thing in MSAL. Another aspect with respect to tokens caching and token refreshing is that in ADAL, the refresh tokens were all exposed to the developer so that the developer could go and implement the caching. But that we just touched upon that briefly before is now in MSAL, it takes care of all the token caching and all the refreshing of tokens for you. And this is considered more secure as well. So we do not expose refresh tokens for added security. Instead, we do provide the interfaces where you can persist the cache and serialize the cache, but it handles all the caching mechanisms and refreshing mechanisms for you. Additionally, MSAL is also providing you an API which will allow you to easily migrate the refresh tokens that you acquired with ADAL previously. It will allow you to migrate those to the MSAL token cache format. This will help to make the update smoother for your users and avoid unnecessary prompts and breaking experience for the users as well. So that's another thing that MSAL provides that you can take advantage of today to update your application. For more detailed migration topic, you can follow the migration guides in our docs that I've mentioned before, and you can see how to update your apps to the new MSAL SDKs. So with that, that's where I'll stop and open it up for more questions and discussions. So if there are any questions in the chat window, please, can you read it out, Stephen? Or
yeah, so there's a question right now which I'm gonna try to explain. So I'll read it high level first. Sure. This person is asking about the different conventions, talking about scopes, claims, and roles in different scenarios, and it feels it's a little bit confusing. Scopes are presenting in AAD under the application in the Azure portal. Claims are illustrated in the jot.ms, and roles in Azure AD, but not P2C. So
yes, this is a very good question, and there is a lot of ambiguity here, but I will try my best to address some of this. So scopes as I mentioned in the Microsoft Identity Platform, we refer to scopes as a combination of the web API or the resource, the API ID or API URL with the specific permissions for that API. So one example of that is if you take the Microsoft Graph API, you can think of it as like graph.microsoft.com is the API URL. Followed by user.read or mail.read, which are the permissions. So a combination of this is considered as the scope for the API, and these are passed in the access token that is returned to you from Azure AD, so that you can these scopes are checked by the APIs to give you access to data. Now coming to claims, these are some of the information that come in the ID token specifically. So claims are basically the protocol terminology for some basic information about the user's identity or in the ID token concept comes mostly in the context of an authenticated or signed in user. So Azure AD also issues ID tokens when your user signs in, which contain some basic information about the user like username, their first name, last name, some email or phone number, some of the basic information. These claims, you can also configure them to add more additional claims in the platform, but that would have to be configured explicitly by your admin. So that is what claims refers to, and it's mostly a concept coming from the OpenID protocol. Now, the third part was about roles. So roles are more about giving authorization to a specific set of access restrictions to a specific group or set of users. So you can assign roles to users or applications in the Microsoft Identity Platform. This would again have to be configured in the tenant or through the Azure portal. And once you've configured that, you can get these roles as when you're making requests. So there are different ways to get this role information, and you can incorporate that in your decisions about authorizing access to your applications. So when a user authenticates, you can get some information about their role in addition to their identity and make a decision whether you want to let them access the application. So like an admin role or just a reader role, you can have these different roles defined. Now, the ways to get these roles, there are different ways. I'll just briefly touch upon them. One way is you can get it in as a part of the claims in the ID token. Another way is you can even query the Graph API for with information about that user, and it will return the role information for that user, like what roles and groups that user is assigned to. I hope that helps.
Yes, so we have 1 minute left and a couple of questions. So I don't know if we'll get to both of them, but also please take some time to fill out the post-event survey. I really appreciate it. If you do, that will be helpful for us in the future. So one question real quick is client ID plus secret method uses application permissions which require a very high privilege and cannot be granted to every app development. What is the best way to allow a Daemon app with least permission mode?
That's a great question. And that actually reminds me, I wanted to mention that you not only can use client secret in the client credential flow that I talked about, you can even have certificates. So one option is you create a client certificate in your system, and that is actually recommended for production apps, is to create a client certificate. Now, to address the question specifically about having more secure option, Yes, you can. We do have the concept of managed identities where you as the application owner don't have to manage either client secrets or client certificates, and you can make it more secure by not having to manage these credentials and let the system manage it for you. And that's what managed identities provide. However, a quick note here, we do not support managed identities integration in MSAL specifically. We do have other SDKs called Azure SDKs where you can use managed identities, and Azure SDKs do leverage MSAL under the hood. So that's another whole topic, and we can probably cover that in a future session, but that's a great question.
All right, we're going past the hour, but I don't know if you have time for one last question.
Yeah, sure. I'll try my best to make it short.
All right. When one API calls another API, but both of them are registered under different client IDs and secret, how does one API call the other securely, I guess?
Sure. So this is where the on behalf of flow would help. So if you have one API, I'm assuming it has already received some token from an authenticated client. So the on behalf of flow works when you have an authenticated user in a client and you have called a backend API, and now this API wants to call another API, and they can have different client IDs and secrets. That's actually how it should be. But if you want to call the other API, you again need to obtain an access token in this current API. And that's exactly what on behalf of Flow allows you to do. You just provide the access token that you just received to this flow, and then it will exchange it and issue you another token for the new API that you want to call. And as always, you would need to provide the scopes for that API in this configuration when you're configuring the on behalf of flow. Hope that's helpful.
All right. Thank you so much, Navya. And thank you, everyone, for joining us today. Please take some time to fill out the post-event survey. Give us ideas on future topics that you would like us to cover. We would really appreciate it. And thank you again. Have a great day.
Thank you, everyone. That was a good session and good questions. Thank you.